Hi, I'm Leland Wong, and this is my Kinematics movie project. My theme for this project was swimming, because I am actually a swimmer. And just a side note before I begin is that the speeds I talk about in the video are approximate values that I got from Best Fit Lines, but I couldn't include the graphs into the videos. So let's continue. Okay, so my first topic is the difference between scalars and vectors. Scalar and vector values are very similar with one major difference. Scalar values only have magnitude, whereas vector values have both magnitude and direction. An example of a scalar value is John walks 5 kilometers per hour. Example of a vector value is John walks 5 kilometers per hour north. Here's an example of a scalar. In this clip, I am swimming at approximately 1.4 meters per second in no particular direction. Using the same clip, I can also show a vector value. Here I am in the same clip, swimming 1.4 meters per second towards the other end of the pool. Now I will talk about the second topic, uniform motion. If an object is moving uniformly, then the object travels equal displacements in equal time intervals. In other words, objects in uniform motion will not speed up or slow down and will not change direction. In the physical world, there is no such thing as uniform motion, but there are many examples of motion that is close to uniform. When a person swims, maintaining uniform motion is impossible, but for this experiment, I did my best to maintain a constant velocity throughout my swim. The next topic is velocity. Velocity is the displacement of an object during a time interval divided by the time interval. In other words, velocity describes how fast an object's position is changing. This means that velocity is always calculated in relation to the origin, aka the starting point. There are three kinds of velocity: positive, negative, and zero. An example of positive velocity would be someone walking north away from their house at 5 kilometers per hour. The house would be the origin, and the person therefore has to have positive velocity because they are moving away from the origin. Then the person stops for a rest for an hour. This is an example of zero velocity. After walking for a bit, the person feels tired and begins walking home at 10 kilometers per hour. This is negative velocity because the person is moving backwards towards the origin. Velocity is calculated by subtracting the initial position from the final position and then dividing it by the final time minus the initial time. This is the equation to show velocity. So velocity is equal to delta x over delta t. Delta means the change in. Now I will demonstrate negative, positive, and zero velocity while swimming. As I swim away from the origin, or the wall, I swim with a velocity of 1.52 meters per second forwards. Then I stop for 7 seconds, which means I have a velocity of 0 meters per second, or zero velocity. Then I finally turn around and swim back towards the origin, or the wall, with a velocity of 1.83 meters per second. Now I will talk about acceleration. A change in velocity, positive, negative, or zero acceleration, occurs when the speed of an object changes, or its direction of motion changes, or both. To find the change of velocity, aka acceleration, subtract the initial velocity from the final velocity. Like velocity, there are three kinds of acceleration: positive, negative, and zero. If an object has positive acceleration, the object is speeding up. If an object has zero acceleration, the object is not speeding up or slowing down, but maintaining its speed, or uniform motion. If an object has negative acceleration, it is still moving in a straight line forward, but is simply slowing down, or decelerating. Before calculating acceleration, one thing to note is that acceleration is always measured in meters per second squared. To calculate acceleration, you subtract the initial velocity from the final velocity and then divide it by the final time minus the initial time. The equation to solve for acceleration looks very similar to the equation to solve for velocity. A is equal to delta v divided by delta t. Delta v is equal to v final minus v initial. When I push off the wall, I have a positive forward acceleration of 2.17 meters per second squared. Then for the next 10 meters, I have zero acceleration of 1.35 meters per second squared. Then for the final 10 meters, I have negative acceleration or decelerate to 1.25 meters per second squared. The final topic I'll be talking about today is gravity. One of the most common examples of constant acceleration is gravity. When an object falls near the Earth's surface, it is attracted downwards by gravity. The speed at which an object accelerates at due to gravity changes depending on the amount of air resistance the object puts out. Air resistance depends on the speed, size, and shape of an object. Acceleration due to gravity is approximately g is equal to 9.8 meters per second squared downwards. So in this clip, this is me jumping off a 3-meter diving board. It takes me approximately 1.1 seconds for me to jump off the 3-meter diving board and to hit the water. And by using a special formula, we can determine what velocity I was going at when I hit the water. This is the formula I can use to determine my velocity. It is the change in velocity is equal to acceleration times the change in time. In our case, it is negative 9.8 meters per second squared times 1.1 seconds. Now you might be wondering, why is it negative 9.8 meters per second and not positive 9.8 meters per second? That's because downwards is considered a negative value. So after plugging everything into the equation, we get negative 10.78 meters per second. This means that I had a positive velocity of 10.78 meters per second when I hit the water. Okay, so that concludes my presentation. Sorry I went a little over time, but I just wanted to make sure I went over every single little thing in detail because I wasn't really sure about some things. But yeah, so that concludes it. Thanks for watching, and yeah, Leland out.